Discuss the trends in chemical reactivity of group 15 elements. Now, this is a very interesting and a very wide, all-encompassing question. It has many ideas, many concepts involved. So first, I'll give you some very general ideas. Number one, if you look at nitrogen N2, nitrogen exists typically as N2, and N2 contains N triple bond N. It is one of the strongest bonds in nature. Nitrogen is very, very happy and very stable as N2, and that is why dinitrogen becomes inert. Yeah, this is unreactive. Oh, has it become like a noble gas? Not really. It is of course more reactive than noble gases, but then compared to all other gases, dinitrogen has very poor reactivity. Why? Because it already is quite stable. So, elemental nature, if you see, most inert element in the whole family is nitrogen. Why? Because N triple bond N is very, very stable. Please remember, atomic nitrogen is very reactive. If you can break this triple bond and just convert it to nascent nitrogen, that would be very, very reactive, but then that is not the state in which it exists. So all you have is N2, and N2 is fairly nicely, happily inert. What about phosphorus, arsenic, antimony and bismuth? Top to bottom, the group is not very reactive, honestly. Bismuth is also a very dull kind of a metal. I would not say it's a noble metal, but yes, it is not a very reactive metal as well. So nitrogen is a non-reactive non-metal and bismuth is a non-reactive metal. So by sandwich theorem, everything is non-reactive. There is no sandwich theorem in chemistry. Phosphorus, arsenic and antimony are relatively more reactive as compared to top and bottom nitrogen and bismuth elements. Please note, I am not talking about compounds. I am not comparing the reactivity of their compounds. I am just talking about if we have elemental nitrogen, phosphorus, arsenic, antimony and bismuth, you find elemental nitrogen is N2, which is least reactive. Elemental bismuth is just bismuth metal, which is also not very reactive, but at least bismuth is a little more reactive often as compared to nitrogen. Now, when you talk about phosphorus, arsenic, antimony, they are kind of golmaal. Interestingly, the question has been asked in NCERT, but the answer which they might be expecting from NCERT is not given in NCERT, which is the beauty of NCERT. They can ask you anything without telling you anything. Why? NCERT is giving answers. I'll tell you what NCERT writes. But before that, let me just answer the actual question. The question is a good one. The only problem is the answer is very vague given in the text. Now, we talked about a general trend. Reactivity with water. Can they react with water? No. Nitrogen, phosphorus, arsenic, antimony and bismuth. Each of these 5 metals under room temperature and pressure has absolutely no reactivity with water. As a matter of fact, phosphorus is very reactive. White phosphorus can burst into flames in oxygen or in air at 35 degrees Celsius. Still, phosphorus is kept stored under water. Why? Because it does not react with water and it does not dissolve in water as well. So the full family is unreactive towards water and they're also insoluble in water. I repeat, I am not talking about any compound, I am talking about elements. Nitrogen element, phosphorus, P4, arsenic, antimony, bismuth, in elemental state, they are totally unreactive towards water. The second point, these 2 points are not clearly given in NCERT. Why the hell are you speaking them? Because they are the correct answers to the question which is asked. Okay. Now, about a wrong answer which is given everywhere. Why? Why are you giving a wrong answer? Because it is given in NCERT, it is given everywhere, so that you shouldn't feel that I am escaping out some things. I am giving you, and probably if the question is asked in board exams, they will expect you, they will expect the stupid answer from you only. So just to satisfy their expectations and so that you can get marks in board exams, I am giving you a wrong and a misplaced answer which is mentioned in NCERT. What is that? I repeat, I'm not doing it out of happiness. It is just that you don't care for science much. You rather care for the marks. So that is, we have this unfortunate trend in our education system. So I'm telling you the wrong answer and also why it is wrong. I'll tell you both. NCERT, when it comes to chemical reactivity, mentions 4 points. 1, reactivity with hydrogen. Second, reactivity with oxygen. Third, reactivity with halogens. And fourth, reactivity with metals. Out of these, the correct answer to this question is only in fourth part, which is metals. If you are examining the reactivity of halogens, of group 15 with metals, typically they tend to form M3X, where metal is +1 and X is -3. X is not halogen. This is group 15 element. Okay. So typically they form tri-positive anion. Yes, tri-negative anion. Yes, they form a tri-negative anion. Like they form nitride, phosphide, arsenide, bismuthide, antimonide, and even bismuthide. For example, if they react with alkali metals or alkaline earth metals, like you get compounds like sodium bismuthide, calcium phosphide, magnesium nitride, such things are possible. So typically they form -3 anion when they react. Honestly, this is partially correct. This is what is mentioned in NCERT, I'm telling you this, and this is what is expected for you also to write down. But the true question is the trends in reactivity. That means, can we compare how reactive is nitrogen as compared to phosphorus or arsenic or antimony or bismuth? Such data is not mentioned. And although I can tell you, but I don't think I should bother you so much. If you write this much, it is sufficient. I repeat, scientifically, this is not the answer to the question which has been asked. Anyways, why you're making so unnecessary fuss? Question is there. My answer is there. We are getting marks for this. Why should you worry? My worry is the murder of science, nothing else. And I think one should worry about this. Now, the problem is, they have also mentioned that you should discuss the trends in reactivity with hydrogen, but they have not mentioned how reactive is hydrogen towards nitrogen, phosphorus, arsenic, antimony, bismuth. The same they have not mentioned for oxygen and halogens as well. The trends they have not mentioned. They have just told you the outcome. Like with hydrogen, you get EH3. For example, nitrogen can form NH3, phosphorus can form PH3, arsenic can form ASH3, SBH3 and BiH3. They mention this, that these hydrides are possible. And then they start talking about the trends of reactivity of hydrides. I repeat, this is not the trend of reactivity of the elements. But since nothing else has been given, I'll just mention. Down the group, bond length, increases. So you find stability decreases. That means ammonia is more stable and bismuthine is least stable. So reducing power increases, and not just that, basic strength decreases. I've told you 4 properties. We can talk about more also, but again, this is what is expected for you to write down the trends. But I repeat, these are not strictly speaking trends of reactivity of elements. These are the trends of reactivity of element hydrides, which is best explained in NCERT. Nonetheless, this is as regards hydrogen. What about oxygen? With oxygen, they can form E2O3 and E2O5. Typically, all of them can do this. N2O3, N2O5, P2O3, P2O5, AS2O3, AS2O5. Typically, because they both show oxidation states of +3 as well as +5. That's it. And not just that, amongst E2O3 and E2O5, more acidic is +5 state, and +3 state is obviously relatively less acidic. But then, this is not the trend of reactivity. I know that this is not the trend, but this is the only thing which is mentioned in NCERT, and this is the only answer you're supposed to give if you want to get marks. This is a match fixed. What about X2? Murder of science continues. In X2, you have, well, you can form EX3 as well as EX5. Nitrogen will give you just NX3. Nitrogen will not give you NX5, but E can be phosphorus, arsenic, antimony. To some extent, bismuth also, but bismuth also loves forming just +3 because of inert pair effect. Nitrogen does not form +5 because there is no presence of d orbitals in nitrogen. Nitrogen cannot expand the octet. Bismuth can expand the octet, but bismuth doesn't want to expand the octet. It just stays because of inert pair effect. Bismuth just loves to stay in +3. So you have BiX3 also. Although bismuth can form BiF5, that is possible, but fluorine is more reactive, so it can form BiF5. Chlorine can form BiCl5 with great difficulty, and BiBr5 and BiI5 do not exist. So for all practical purposes, nitrogen and bismuth just go to +3, and others can go to +3 as well as +5. I repeat, these are the properties of the products. This does not explain the trend of reactivity, nor has it anyway been mentioned. This is the expected answer, although this is very different from the question which has been given. But this is a standard popular answer everywhere on earth, and this is what is expected by NCERT also. So my suggestion for NCERT people, change the question or give more data in the answer.